Density is one of the most important physical aspects of a green coffee beans for us roasters, and this is why we're going to have a close look at density in coffee in this video. In the first part, we will be talking about what actually density is, so I explain you the concept of density, and then we are going to have a look at how to measure density, what is actually affecting density, so why do we have different densities in coffee, and then also how do I roast coffee differently depending on their density. Then at the end, we are going to have a look at some different devices or tools to measure density. So this is it, but now let's go with the video. Density explains how much weight you have per certain volume. So you might probably remember it from school. If you have a bag at one size and you're going to fill them with feathers, then it's going to be much lighter, even though it has the same size, than if you're filling the same bag with stones. So the bag with stones has a much higher density than the bag with feathers. And this is mostly coming from the air that is between the parts. So the bag which is much heavier, the one with the stones, has less airs between the physical parts, so much more parts in the same volume than the bag with the feathers. And in coffee, it's about the same, of course, a bit less extreme. But if I'm going to show you here these two cups, you see I have both cups filled with 120 grams of green coffee beans. This is a Monsoon Malabar. This is a washed coffee from Kenya. And you can see, while this cup is nearly filled to the top, this one is about filled to, let's say, 60%. So there's quite a difference in the volume in these cups. Although it's the same amount of green coffee beans, it's in both cases 120 grams of coffee. And then when you're looking at the green coffee bean itself, you can imagine it a little bit like a sponge, for example. So you have sponges with a bit bigger holes, with a bit more holes that are a bit fluffier. And then you have other sponges which are much, much harder to press, which are much denser. Then the same applies for green coffee beans. So a coffee with a higher density has much more parts in the same volume than a coffee with much less density. So what is actually affecting then the density in green coffee beans? Where does the different densities are coming from? And there are some aspects that are playing here a role, and one of them is, of course, the cultivar of the bean. So the different cultivars can have different densities. It can be the processing of the bean. Then it can also be how much water is inside the bean. Therefore, if you measure density, it's also interesting to measure then moisture content of the bean, because water is a bit lighter than the physical components in the green coffee bean. So if it has a bit more moisture content, then it's usually a bit less in density. And one aspect that you might have heard of quite often when it comes to a correlation with density is then the altitude where the coffee has been grown at. Altitude is actually not a super precise descriptor, because it's often then coming from, well, conditions that are affected by altitude, but it's more about the temperature where coffee has been grown. We often think, if you haven't been in a coffee origin, that coffee wants to have high temperatures, because we see coffee is growing like in this coffee belt around the equator. But actually, especially Arabica beans, they don't really like to have too high temperatures. They like a bit lower temperatures. The only point is they really hate if it's freezing at night. So that's why you cannot grow coffee in a bit more northern or more southern countries, but more likely about this belt around the equator. So these cooler temperatures, and especially if the nights are a bit cooler, are affecting that the green coffee is growing much slower. And then when it's growing much slower, it's getting much harder, and it bounces much more elements in it, like sugars, proteins, and so on. And then the coffee is getting much harder. So the altitudes then, of course, plays a role, because at higher altitudes you have a bit cooler nights. But it can also be that the coffee is grown at a really low altitude, the temperature is a bit cooler, then you have a bit harder bean. Therefore, if you want to really then rely and understand what density you have in a green coffee bean, because we're later going to talk about then also the flavor aspects and the roasting of denser green coffee bean, if you really want to know that, then you really have to measure the density of the green coffee beans, which is actually quite simple. So when it comes to measuring the density of green coffee beans, there are actually 2 or let's say 2.5 methods of measuring it. One, and the most common and most often used way of measuring green coffee density, is called bulk density. It's very simple. You just take a cup or something which has a volume that you know. So let's say, for example, you take a cup with, well, the ISO standard would be 1 liter, but in most cases you take probably a much smaller cup. So let's say you take a cup with 250 milliliters, you fill it to the top with green coffee beans, and then you measure how many grams you have put in this cup, and then you divide the grams that you have put in the cup with the volume of the cup, and like that you come then to the density, which is measured in grams per liter. So imagine, for example, you put 150 grams in a cup which is 250 milliliters. So 250 milliliters is 1/4 of a liter. So you would then calculate this 150 grams times 4. So this means 600 grams per liter would then be the density of the green coffee beans. So this is actually a super simple way of measuring density in green coffee bean. Another one, which is then more precise, would be water displacement. You maybe also have learned that at school, because if you imagine here a cup of green coffee beans, not the whole cup is then filled with beans because there is air between the beans. And the different shapes of the green coffee bean can affect how much air there is between the beans. So especially with a bit larger beans, if they are on top of each other, there might be a bit bigger pockets of air between them than if you put in smaller beans. And this is why then water displacement would be actually a more precise way of measuring density. When you're using water displacement, then you put in water to a cup. So let's say, for example, you have a cup and you filled this cup until 1 liter. And now you put in green coffee beans until then the water is reaching the level of 2 liters in this cup. So make sure you take a big enough cup. Then you can measure, for example, now you have put in, let's say again, 600 grams of green coffee bean and the water level was rising from 1 liter to 2 liter. So you know you have had a density of, again, 600 grams of 1 liter. This is actually more precise. And some roasters are preferring to use water displacement, especially, for example, if you have a look at the video that I did with Rob House. He's a person that is using water displacement. I am then always a little bit criticizing here that you're spoiling the green coffee beans because you put the green coffee beans in water, you cannot roast or use them then afterwards. But the way Rob is, for example, doing it is he's taking really a very, very small cup where he's then displacing only a few milliliters and putting in just like, let's say, 10 or 12 grams of green coffee. So he says he's only spoiling really a small amount of green coffee beans. So just for you to know, this is a method that you can use. Most roasters, nevertheless, are still using then like the bulk density method to measure the density of green coffee beans, just for the reason that it's super simple, that you're not spoiling any green coffee bean. And then it's always a little bit of a discussion on how precise anyway you want to be. Rob, for example, who is using the water displacement, he's then really like a scientific guy who goes into details and then does a couple of hundreds of roasts and analyzing them. For most roasters then in practical use, it doesn't really make a difference in the roasting whether you have 810 or 812 grams of density in the green coffee beans. You're more likely just to look in bigger steps, like if it's then like 650 grams, 700, 750 or 800. So you don't even need that precision, and in most practical cases it's really enough and working really well with bulk density. I also announced you that there is like 2.5 methods, because there is also kind of a digital or like a calculated way of measuring then the real density, so the water displacement density. This is now happening with the DiFluid Omix, so we are going to have a look at these different tools later. The DiFluid Omix is then, measuring the weight of the green coffee bean in a cup. So it's using kind of bulk density, but it has then a sensor which is then reading the structure of the sample, and it sees how big these holes are between the green coffee beans, and then makes a calculation and calculates then a kind of virtual water displacement method. So this can be interesting for you if you want to have a little bit more precision. In most other cases, all those tools that we are going to have a look at later are actually measuring any way of bulk density. You might have heard that there is a correlation between quality of the coffee and density of the coffee. So, for example, then when you're sourcing green coffee beans, you often hear then also factors like, for example, strictly hard beans, which are then the denser beans. So let's say, for example, for some Central America countries like Guatemala, you hear then a categorization of soft beans, hard beans, strictly hard beans. So hard beans are better than soft beans. Strictly hard beans are even better than hard beans. So they categorize it a little bit in that aspect. For other countries, they use then like expressions like high-grown coffee, strictly high-grown coffee, which then brings in again the play of the altitude of the coffee, which has a correlation of the density as said before. And just in general, you can say that in general, green coffee beans with a higher density have a better cup quality. When we are talking about better cup quality, then we are always referring to the SCA scale. So you say, in general, a harder or a denser coffee is most likely going to have a higher SCA score than a less dense bean. I'm expressing it especially bit in that way because like a better cup quality doesn't always mean that you are more likely to like this coffee better. If you're a person that is into specialty coffee, light filter roast, maybe coffee competitions, then yes, then you will be more likely to like denser coffee or coffee with a higher SCA grade. If you're going out there and then serve a coffee to your family or friends who are not deep into coffee, in my experience, it's very often that most people are really tending to like coffees that are somewhere in the 83 or 84 SCA points. So just for you to know, when we're talking about better quality or better cup scores, it can mean that those coffees are more to your taste, but it can also be that you are more likely to like coffee that have a bit a lower density. Like, for example, a lot of people love naturals from Brazil, which has been grown at a bit lower altitudes. But in addition to that, it's also a fact that some green coffee defects can affect density. So if you have defects in green coffee beans, it is very often that then these defective green coffee beans are a bit lower in density. So in general, you can then also make a correlation between density and then really quality of the green coffee beans when it comes to explaining that the coffee is less defective. So those two factors are playing a role so that you can say in general, very often a denser coffee is better in its cup quality than a lower density coffee. So for you as a roaster, it's now the question, what are you going to do with this information? If you know the density of a green coffee bean, what are you going to change or do differently in a roasting machine? So one thing in general, if you are a bit more into this like specialty coffees, into coffees which are a bit more flavorful, more floral, which have a bit more like fruity, a bit higher acidity, then you are more likely to roast coffees a bit faster, then you're more likely to use a little bit a faster roasting style. While on the other hand, if you are more into like a bit full-bodied, less acidic, a bit more complex coffees with maybe a little bit more chocolate notes, then you're more likely to roast a little bit slower. And this style of roast is then also correlating with the green coffee beans that you are taking. So in general, to give you an understanding on what's happening in the bean, there was quite a nice picture that Chris Corman did in his book Green Coffee, and he explained it a little bit with like to imagine that a green coffee which is denser is a bit like a cast iron pan, while a green coffee which has less density is a bit more like a stainless steel pan. So the cast iron pan will need more energy to heat up, so you must put more energy in it. But then once it's hot, it's keeping the heat a bit better, or like much better than a stainless steel pan, which is much faster in heating up. But then also when you take heat away, it's then also cooling much faster. When it comes to the roasting procedure step by step, the first aspect is the preheating of the roaster. Since you often want to roast these denser coffees a bit faster because there are these more flavorful kind of coffees, you usually want to preheat the roaster to higher temperatures in order to have then more energy saved in the system. And you can also do that really well with higher dense beans because they are less likely to scorch, to get burned spots on the surface when you put them into a hotter drum. So you can preheat, and you're more likely going to preheat the roaster a bit to higher temperatures if you have a denser bean, while if you have a less dense bean, like here for example this Monsoon Malabar, these are going to scorch more likely, so you have to be a little bit more careful with the preheat temperature on the drum. And now there is a thing, when you have put the beans in the roaster and you're starting the roast, you in general want to apply, as I said, more heat in the denser coffee, but just in the very first part of the roast you have to be a little bit careful because the green coffee is still cold and it takes a little bit more time for the heat to get into the bean and heat up the whole bean when you have a denser coffee. That is why in the very first part of the roast you are going to be a little bit less aggressive with the heat application in a denser bean, because if you're too aggressive, then the water at the outside of the bean is going to dry, and then you have a risk of then scorching the bean. This is why you are going to be a little bit less aggressive in the first seconds of the roast with the denser bean, while with the less dense bean you can then already start to applicate quite a lot of heat directly from the beginning of the roast. Then the next point where you're going to roast these beans differently is the first crack. As I told you in the example of the cast iron or stainless steel pan, when it comes to first crack, then the beans are going to turn from endothermic, so before they're taking energy, you have to put in much energy, to exothermic. So the beans are releasing energy themselves. So you have to then really manage the roast after the first crack. As you most probably know, may have roasted some coffee before. And when it comes to denser beans, they have saved much more energy inside. So when it comes to denser beans, they will have much more heat going through the first crack. So you have to be a bit careful and not applicate too much heat in the development phase. So you can take the burner a little bit down. While in the less dense bean, they are saving less energy. You have to be careful that during the first crack, they are then not dropping in temperature. So here you can put a little bit more heat than with the denser bean in order then to keep the momentum and keep the beans from dropping down in temperatures, and then manage them through the development phase to get a nice roast out of it. I hope this general information on density in green coffee was helping you. What we are going to have a look at now are different ways of measuring bulk density, or then also different tools that we have here. So when it comes to measuring density, actually you don't need any expensive equipment. Really, as I explained you before, what you can just use is then a standard cup. So for example, this cup, I filled it once with water. I know that this cup is taking 250 milliliters of water inside. So what I'm then going to do is I'm going to put in green coffee beans until the top, and then I'm taking away what's over the top so that it's then really even to the top. I'm measuring the amount of green coffee beans I have put in, and then I can do this easy calculation of how many grams are in this 250 milliliter cup, and then calculate the bulk density. You can use then, on the other hand, also one of these tools. So these tools here that you can see here, so this is the Lighttells MD500. This is the Coffmeter M1, and this is the Omix Plus from DiFluid. They can all measure then the density within them technically, but they're also measuring other factors. So all of them are also measuring the moisture content of the bean, which is then something that you cannot actually easily measure with any other like tools that you have at home. Moisture in green coffee is also a very important aspect that we are going to cover in another video. Once this video is live, I'm going to put it here or in the description. So these tools are then made for measuring moisture and bulk density. All of those are measuring the density in bulk density, except of the Omix, which is then also having this, as I explained before, calculating factor where it's optically measuring the bed or like the sample and then optically finding out where there are air spots between the beans, and like that's measuring how much would be the real, like the water displacement density. So that's going to give you a quite exact, quite precise value, which is then closer to the water displacement density. But what you have to know, and this is important for you, all of those tools, when they come to measuring density, they have kind of a correcting factor. So for example, the MD500 from Lighttells is then adding 8%, and then all of these tools are adding a certain calculating factor. So with each tool where you're measuring density in green coffee, you are going to get different values. This sounds a little bit strange, but it's just a fact. So within themselves, you get a really precise and consistent reading. So if you're always using the same tool, you can really then organize your beans and get a good understanding of the density in it. But what's really, really difficult is to get a value from somebody else. And this is why I really recommend you, no matter which tool you're using, if you're using just a cup like this, or if you're using one of these tools, that you're then really measuring the density for yourself and writing it down for each green coffee bean, and then applicate it in your roaster, because as I explained you before, it's really hard to take the density that somebody else measured, especially if you get it from different sources, and then one used, for example, the MD500, the other one used, for example, the Omix Plus, the other one did it like this, and even then how people are preparing the sample, if they're, for example, then shaking it a little bit, this makes the coffee much denser than if you just overfill it with coffee and then like take away the coffees at the top. So this is just for you to understand that you have to measure density yourself. Don't rely on the data that you get from somebody else. And as said, it's super simple to use density actually. Now let's go through these machines that I have here. The first one here is like the working horse. It's the oldest machine in the market, and it's one that has been used for years by roasteries very intensely, also by competitions. It's the Lighttells MD500. This machine measures the density, but also the moisture content in coffee, measures also then the environmental temperature. And all of these devices can, by the way, measure moisture and density not only for green coffee beans, but also for roasted coffee, for parchment coffee, and then also for the whole cherries. So they're not only interesting for roasteries, but also for green coffee producers, green coffee traders, who then have also the steps before, like the parchment coffee or the whole cherries. The MD500 is very easy. You're then going to fill this cup to the rim, and then you're going to put the beans in the machine, to take this stick out, make it a bit more beautiful than me, so that all the beans are landing in the device. You press a button, then within a second you get the values. The values then are also saved on the machine. Then here you have a pretty new device. This is the Coffmeter M1. It's produced by DiFluid, who is also then producing the Omix Plus, for example. What you're going to do here is filling the beans to the rim, putting the beans that are overspilled away so that it's really even to the top. Then you're pressing the button, and you also get then the moisture content and the density of the green coffee that you are putting inside. What's nice about this tool is that it's quite cheap, so the price for this is really competitive. And another aspect that I also like about the DiFluid tools is they have a connection to an app, so you can then also track it there and save the values there in the DiFluid app. And then here you have a device which can do quite a lot. It's the Omix Plus from DiFluid, and this is on one hand then measuring moisture. It's measuring not only moisture but also water activity. So water activity explains how fast water is then moving within the bean structure. It's measuring the screen size of the bean. And when it comes to density, which this video is about, it's going to measure, like the others, also bulk density. So we're going to fill this cup until it's full, then put away the overfilled beans, put it inside. So it's on one hand, measuring the bulk density, but it also has an optical sensor here, which is then checking the surface of this sample and is looking for air between the beans. And then it calculates the sample in a way that you get the real density, how it would be if you would be measured in water displacement. In addition to that, it's also measuring then the color of the roasted coffee. So you can then measure the color of ground coffee, whole green coffee beans. So it's then really the tool that you can use in your roastery for everything from sourcing the beans to the information that you need for roasting the beans, and then also for the quality control when you have roasted the beans. So it's like an all-in-one tool, which is really handy, which is really nicely made, and also has a connector to an app. I hope this video was helpful for you. If you want to know more about coffee roasting, green coffee beans, or different roasting tools, then have a look at the other videos in our channel as well. Also make sure you subscribe, because we are releasing regularly new videos on coffee roasting. If you are interested in the different measurement tools, like the ones from Lighttells or from Coffmeter, DiFluid, then make sure you have a look at our website where I explain them all in detail, or you can always come back to me if you have questions. You find all the tools and my contact on roastrebels.com.